I'm your mental curator, Johnny Hemberger, and it is my privilege to welcome you to another wonderful episode of the HMNS Beyond Bones Podcast. Recently, our own astronomer, Tracy Knauss, had an asteroid named after her. So I made the short trip out to our HMNS George Observatory campus in Brazos Bend State Park to talk with Tracy about our 36-inch telescope, astronomy, the importance of dark sky sites, and, oh yeah, just how does someone actually go about earning the honor of having a real-life asteroid named after them? Well, sit back, relax, and enjoy a down-to-earth conversation about some out-of-this-world astronomy. Tracy, thank you so much for coming on the HMNS Beyond Bones podcast with us today.
I am glad to be here.
So we are in the dome, the main dome at the George Observatory here at the Brazos Bend State Park. And as I understand it, there has been an exciting development with an asteroid that has wound up being named after you. So can we tell that story from the beginning? How did that happen?
So how did that happen? Comet Tempel 1 is how it actually originally happened. We were out here gathering information with the University of Maryland to get a more precise orbit for Comet Tempel 1 for NASA to land a satellite on the comet to see what a comet's made out of. But in the interim, the group shot an asteroid.
And what was the involvement? You were telling me earlier off camera that we needed more measurements on helping with the orbit.
They did. So they needed a more precise orbit. We knew a roundabout orbit for Comet Tempel 1, but they wanted a more precise because they're launching their unmanned satellite. This thing's up in orbit. Right. We need to know exactly when they cross.
Exactly. Yeah, you can't just launch. It's like launching a bottle rocket.
Right. You can't just say, oh, it's close.
Exactly. Close enough.
Exactly.
No.
It'll work.
There's no such thing, especially with NASA and any space agency especially with trying to land a probe on an asteroid.
Yes.
There isn't, it's close enough. From our perspective on Earth, if we're a millimeter off, if you're a millimeter off from Houston, Texas, you are billions of miles
way off
in space.
Way off. So
that's really cool that the observatory was used to more precisely track not just where the asteroid is, but also where it was and help you find out where it's going and those extra data points to figure out, where do we need to aim this probe
Exactly.
So how did it become, when was it first discovered and why was it named after you?
So it was originally discovered, Palomar Observatory originally observed it back in 1954.
Ooh.
Yeah.
Okay.
And then our group, what we used to have called the Asteroid team, they would go out and hunt for asteroids. And of course they stumbled across this one. And because they did so many observations, they got a number for the actual asteroid. Mm-hmm. And then with that, because they were still observing it, they could actually name it. And they just decided to name it after me for promoting astronomy to the public.
So do you know the actual name of the asteroid off the top of your head? Because I know it's probably your last name.
It is, yes.
Do you remember the string of numbers?
Do I know? So it's Knauss, something like 23123 or something like that. Because that was the original number that the asteroid team had got with the asteroid team.
And we do have all that documentation. I'll pepper in B-roll. If you're watching this on YouTube, and I highly recommend you do, because behind us is our giant 36-inch telescope. I will provide that material for you to see what it was named, the actual numbers. But I want to talk about the nuts and bolts, the rock and gravel behind not just discovering an asteroid, but what do those numbers and letters mean when somebody's looking up an asteroid?
So initially, if you turn in your observations, they go to the Minor Planet Center. They decide yay or nay, whether it's real or not, whether you've done all your astrometry, whether it's correct. Then they assign it a month that it was discovered in and the day it was discovered, and then it gets an alphabet. And depending on where in the alphabet it is, that lets you know where in the month it was discovered. And then after you do more observations and get more of a precise orbit of this object, then they assign it a 5-digit number in the case of an asteroid.
Right. And at what point specifically do you get your name on it?
At what point do I get my name? After they've done at least 10 to 15 observations, sent them in, they're all correct. Okay. Then they get the opportunity to, hey, you can name this asteroid.
Right. You've done the legwork. We've
we see that you're actually into doing all the work for it. Yes.
Right. This is totally legit.
Yeah.
You put in the legwork.
Exactly. You sent in the information. Okay.
It's verified. Peer reviewed. Everyone agrees. Then this is legit.
Now you can name it. And it's up to the asteroid team to decide who they're going to name it after. So I didn't even know.
Interesting.
No, so I had no clue.
You can't just say, hey, can I be considered? So they came to you and said.
They did. They surprised me.
That's cool.
So it was actually at their meeting, their Fort Bend Astronomy Club meeting last Friday. They knew I was going to be watching. Yeah. And they're like, at the end, they're like, oh, and by the way, we named this asteroid after you.
That's so cool.
So it's really cool. Such an honor.
And it's not a little speck of dust out there. I guess cosmically speaking, an asteroid is small.
Oh, yeah.
How big is this asteroid?
So this one's roughly 30 kilometers across. So, yeah, actually fairly big.
We were talking off camera how big 30 kilometers would be in relation to where we are right now, effectively, Houston, Texas. And maybe that's not from 610 east to 610 west or whatever, but it might be downtown out to Montrose and then out the other way to Edo or something like that. That's
fairly big.
Rock.
That's fairly big.
And do we know the composition? Do we think it's just a solid rock, or do we think it's kind of a?
We know it's a main asteroid. Main asteroid. That's all we know. Do we know the composition? No.
It is a no threat, as I understand it, from hitting anything.
It's far enough away. It's not going to come hit us. Right. No.
But a 30-kilometer asteroid would be a city killer.
Oh, yeah.
Not a state killer, if not
one of the reasons why NASA keeps track of it.
Exactly. We need the asteroid hunters out there and comet hunters out there to know what's coming. I think, what is it, C20? I did with Carolyn a few months ago, and there was a slight concern that this asteroid, C whatever 2024 YR
was going to get close.
Right. And there's like it's at the highest of hitting Earth, there's like 0.02% or something.
I mean, NASA put alerts out when they get close.
Yeah.
But we have quite a lot of them that get close that we don't put or NASA does not put the alerts.
We don't need to alarm the public.
No, we really don't, because then there's mass panic. You know?
Exactly. But that asteroid, I think, has a higher chance as of now. And the percentages keep changing.
Right.
Hitting the moon.
Right. And as they get more and more information, because everybody, starts sending in information, now they can plot a better course on that.
You know what's so cool about, you're talking about sending information to NASA and different space agencies. You think that it's all just official government people and black helicopters and SUVs. It's not.
It's not. It's the amateur astronomers that are doing a lot of the legwork in helping NASA. I mean, NASA's only got so many people.
Right.
They can only do so much. And then they go to the amateur community and say, hey, we've got these, in that case, near-Earth asteroids. Can you gather more information for us?
Right.
And we do.
Citizen scientists. But
yes, exactly.
I mean, legit, that is so cool to me. The idea that I could be out there with I've just got an 8-inch Dobsonian. I don't know how much help that would be in my case, but theoretically, I could be the 8-inch Dobsonian that I have. I could be looking at the moon or at Mars or something and see a flash on Mars. And maybe I'm the only one that evening that captured that.
Exactly.
And now it's legit. Now it's official. And
there may have been somebody else that captured it. They didn't realize it at the time because they were just imaging the moon. It's like, I'll get to working, developing my images. And now it's like, I'll go develop them.
Exactly. Somebody in Georgia sees a flash on the moon. And then somebody in Oklahoma is, I was taking snapshots or whatever of the region at that time. Let me go back and check. Do we have 2 images now from 2 locations?
Right.
Or maybe dozens of locations.
And it can be around the world.
Yeah.
I mean, that's a great thing about the astronomy community. We all work around the world.
Right.
Because there'll be times it's like, okay, I'm clouded out here. Hey, can you shoot some images for me? Sure.
We got a question. I see the question, not like the museum gets a question specifically about this, but I see this question all the time in the YouTube comments and podcast comments and things like that. So as we are recording this, we are within a window of the Perseid meteor shower.
Right.
Maybe we're on the tail end of peak right now.
We are now.
As we've moved through the tail of this comet, I believe, is what caused it. But somebody in Florida asked, like in Miami, will I be able to see this in Florida? And then somebody in Seattle asked, will I be able to see this in Seattle?
Yes.
Yeah, with a meteor shower.
With a meteor shower, you can.
Yes.
Yeah, because the meteor showers have different peak times, and it's not just minutes. It's usually days.
Right.
We do have one night where it's the highest peak to see a meteor shower. So yeah, with the Perseids, and a lot of times with meteor showers, you want to look at the moon phase. If you've got a full moon, it's kind of a meteor shower killer.
Yeah, it's like,
but if not, then it's like, go for it.
A full moon, it would be like trying to watch a dim TV and someone has a spotlight in your face.
Right, exactly.
You got to see through the shine. You can't make it out there. Your eyes adjust their exposure for the spotlight, and you can't see the TV. So, yeah, full moon is not great for seeing the Perseids. But the question was, can I see the Perseids from Florida? Can I see the Perseids from Seattle? For something like the Perseids, like a meteor shower, the whole Earth is going through.
Yes.
So anywhere on the planet, and it's nighttime and you don't have clouds.
Exactly. We all go through day and night.
You could theoretically observe.
Yeah.
But I understand the confusion because not everybody can see a solar eclipse.
No.
For instance, there are some celestial anomalies.
You can't. You're in the window to be able to see it.
Right.
And that's just due to the path and how it's lined up on whether you'll see it or not. Now, you may see a partial of a total.
Right.
Yeah.
But that's
nothing.
That's a celestial event.
Yeah, that's a celestial event.
That's like looking through like a knot hole in a fence.
Right.
You have to be lined up right on
it
to see what you need to see through that fence. Versus a meteor shower is just
everybody can see it.
Everybody can see it.
But any eclipses are all depending on where you're at. Typically, you get more with a lunar eclipse.
Right.
But
more people can see the lunar eclipse.
Right.
If the Earth is
the path is actually wider to be able to see that. Whereas a solar eclipse, especially a totality, you're looking at a narrow path, just where the shadow's at.
There's different obstacles. You have to thread that needle better.
Oh, you do.
To see. And that's why people flock to the region of a solar eclipse.
They do.
And it's really cool. It's really
it's kind of a once in a lifetime. I mean, it's kind of an aha moment when you actually see one because it's so unique. With the solar eclipse, everything dims, it cools off, the birds quit chirping. I mean,
there's a creepy.
There really is.
But it's cool. I say creepy, but it's the way the light changes.
Yes, and the temperature, you instantly feel the temperature.
Yeah. You're in the shade. The moon. Yeah. There's the corona around it. And there's different types of solar eclipses depending on how far away the moon is between you and the sun. But in Texas, we got lucky the past year or two that we got two of them cross and pass over the same area. Spot. Like Bandera, Texas got the solar eclipse.
Exactly.
Two different types
Y'all were on the X.
Right. Two different types of solar eclipses right on the X.
The annular and then the totality. Yeah.
And then the next one that the entire country, most of the country, United States, will be able to see in the 2040s, I think.
Something like that, yeah. 2046 or something like that.
So let's go back to the asteroid for a little bit. How difficult is it to see a 30-kilometer wide asteroid?
At this point, you have to be in really dark skies. It's a very dim asteroid. I mean, all things up in the sky are measured in magnitude.
Right.
So, you look at like the moon, it's very bright. This object, the higher the numbers get, the dimmer it gets. So mine is at 18th magnitude. Right. I mean, on a really good night, I might be able to pick it up with a telescope.
What is, off the top of your head, would you know, like the magnitude of Pluto? It's very dim.
Pluto's like
28.
Oh no, it's not. No, Pluto's much brighter than that. Yeah, Pluto is like 14th, 15th magnitude. Okay. So we can easily see that in the scope.
You see Pluto on the 36 inch?
Yes.
Why did I have to come here at 12 noon?
The quest with Pluto is you have to know where it's at because it does look like a star when you're looking through the telescope.
That's a good springboard.
Out there.
I know. See, that's the thing is you could say and maybe somebody listening to the podcast or watching, even an amateur astronomer would say, well, just because it's 30 meters wide, there's a huge 30 kilometers wide, doesn't mean that it's could be any brighter than one that is 10 kilometers wide.
Right.
That's closer.
Right.
It all depends on...
Depends on how far away it is.
Exactly. So there could be, and there is definitely asteroids out there the size of Mount Everest.
Oh, yeah.
That are just so far away that they may appear dimmer than a 15 kilometer. It just all depends. And then it depends on the size. And it depends on where it's at in relationship to Earth. Do you know off the top of your head, I'll bring up the documentation either way, how far away your asteroid is?
So yes, I do. I actually looked it up.
Good.
So it's 6.97 AUs from the sun.
What's an AU?
AU is an astronomical unit. Mm-hmm. So that's how we actually measure once we get past miles, you know.
And did you say that is an AU the distance of Earth from the sun? Is that, what is the measurement? I think that's about right.
Right.
But that brings up another question because the Earth isn't always...
So I'm in the main asteroid belt. I'm before Jupiter, just right before Jupiter.
Right.
Is where that asteroid is located.
And for those unaware, and it's totally fine if you are, the asteroid belt is between Mars
and Jupiter.
Maybe not exactly equidistant, but
it is a path where most of them are trapped in there, and eventually some of them do leave. Yeah,
they leave, and Jupiter is the big disruptor.
Oh, it is because of the gravity of Jupiter.
Yeah.
I mean, it's got a nice pull to keep, and thank goodness because it keeps most of them there, and it keeps it from coming to us.
Exactly. Jupiter keeps the asteroid belt where it is instead of the asteroid moving more towards the sun.
Correct.
And we are in between it and the sun.
Yes, we are.
So it's good that you have that tug of war.
Third rock from the sun.
Yep. You got that tug of war that Jupiter's pulling on the asteroids when the sun's pulling the other side, and it's keeping it right there. It's a stalemate.
Exactly. And
thankfully
thank goodness Jupiter's a big gas giant with a lot of gravity.
Now, and so there are obviously asteroids that exist that are floating around outside of the belt. They're not typically right in the median. And then beyond Pluto, correct me if I'm wrong, the Oort cloud. Yes. It's a whole
another set of, asteroids, comets.
Here's kind of a vague question. So we hear about the Oort cloud less, I feel, than we hear about the asteroid belt.
Oh, yeah.
Just naturally, because the asteroid belt is closer, we can observe it.
Correct.
Have there been, to your knowledge, I put you on the spot right now, have we found any suspicious asteroids in the Oort cloud that NASA or agencies are worried this one's on a track to maybe leave the Oort cloud? Or is that just way too far
out there that we don't really see them until they get in closer? Because at that point, they're very dim.
Yeah.
And more than likely, we don't have enough information on them. So by the time we start working on a path. What is the path for this asteroid? Or what is the path for anything that's coming out that far? The comet, any comet. Because there are comets that come from the Oort cloud.
Yeah, and also, the Oort cloud is so far away.
It is.
That if you found a threat to Earth, it'd be, 600 or 700 years or hundreds of years from now.
I mean,
maybe we'll glance
do we have to worry about it right here and now? No.
Versus an asteroid, something originating in the asteroid belt, that's basically in our neighborhood.
It could be, and especially if it gets thrown out from the main asteroid belt, now it becomes a near-Earth asteroid.
Right, and theoretically, it could be here in a few months.
Yes.
A few years. It's way closer. There's less time to prepare for.
Right, than something that's way out there in the Oort cloud.
Exactly.
That we don't have to worry. We don't have to worry as much.
Right. So, speaking of asteroids, when you come to the George Observatory, and I'll definitely put some B-roll here, there's the parking lot by the visitor center across from the George. You can't see the George from the parking lot. You have to walk.
You do. You have 800-yard path.
I was going to say quarter mile, maybe less than that, 800 yards or so from the parking lot. But along that path is a scale representation of our solar system. So the sun and then out to Pluto, I think, is
right. We do have Pluto there.
Way, way far away from the George. But as you walk down that path, you'll pass markers. Here's Jupiter. Here's Saturn, Jupiter, Mars, and around about where the asteroid belt would be, we have a marker for an asteroid previously.
We do.
Is the George known? What is that? And is the George known for asteroid hunting?
We are known for asteroid hunting. That actual marker is, so that one was named after Brazos Bend State Park, saying that they graciously let us have the George Observatory here. We decided to name one after them. And yes, at the Fort Bend Astronomy Club is highly active as far as asteroid hunting, or they were. They aren't so much anymore because of all the onboard electronic, that's all they do.
Yeah, speaking of electronics and things, I guess let's start with something that I think a lot of observatories have to navigate, and that is human beings spreading out, moving to cities. And the Brazos Bend State Park, once upon a time, was way darker site than it is now. It's still a dark site, darker than, say, being where I live in Missouri City, or
definitely
lived in Montrose or downtown Houston, something like that. But humans keep expanding outward.
They want to go to the country.
And every time I come out here, I want to be one of those people, but I don't want to be necessarily, I don't daydream about being in a subdivision out here. I daydream about having 10 or 20 acres,
being on acreage,
and a barn, and exactly, room for the kids to play and that kind of thing. But the subdivisions, the McMansions, are popping up. I don't mean to be derogatory, but that's...
Well, they are. They're creeping. Right. They're creeping up. They want to, move further out from Houston, get a little bit away from the concrete jungle, but still enjoy part of the country.
So what are some of the things that, if you're a developer, let's do different scales here. As a developer, are there things that you can do to mitigate light pollution? And then let's go even more granular. Let's say your developer isn't doing much to help with light pollution. What are some things that a homeowner can do? So what are things that a developer can do? And then what are some things that a homeowner might be able to do to help mitigate?
As a developer, of course, they can have shielded lights, which won't hurt the community. It'll actually help the community. So you're just putting the light down on the ground where everybody wants it to be able to see. And it doesn't cost you any more.
Right.
As far as a residential, you can help promote that, or even just set it up at your own house.
So we're talking about, street lights and path lights. And you want the ground and you want your area to be lit for safety reasons.
You want to feel secure. Right.
But the atmosphere doesn't need to be lit.
The atmosphere doesn't care. It doesn't care.
It's wasted energy, wasted effort to light the sky, and
actually it would help if we shielded it, because it would also help with the airplanes and stuff like that.
Right.
So
just see the navigate. I play a lot of flight simulators.
Yeah, so they can see where they need to go in order to land.
Right.
And with tons of light going up, that makes it difficult for these guys.
So it benefits everybody.
It does.
When you're thinking about new developments in dark sky sites, it's not just because the local astronomy club would love to keep the sky dark.
But we would.
We absolutely would.
But it's also a
benefits.
benefit for the people that are living there and that want to move there.
Right. It's a benefit for the human beings that live there. It's a benefit for the animals and the birds and things that navigate. It's a benefit to air traffic. There's so many benefits.
There's more benefits more pros than there are cons.
The only con I could conceivably think of is if that light shield cost 5 cents more to install. And
it doesn't really. If you're doing it from the beginning, there isn't any different really in cost changing one light. I mean, because most lights, there is a range for lights.
Yeah.
But there's no difference in all reality as far as cost.
There's things you can do at groundbreaking, and there's things that individual homeowners can do to help mitigate. You talked about the residents there would benefit from it also, if anything, because if you live so close to a state park and you want to keep nature, and one of the reasons you come out to the country is to be in the country.
Yes, you do.
Then there's an incentive to keep it country. It's
incentive to preserve it, especially out here, because out here we're also on the migratory bird trail or track. So we get the hummingbirds coming up, plus the monarchs. So you want to preserve that, otherwise they will eventually die out.
Right.
So you definitely want to keep that. And it's an incentive for everybody.
That's what I'm saying.
Everybody loves to look at nature. Everybody likes to see those little Hummers just flitting about,
It would be ironic.
I mean, think about the world without it.
Yeah.
It'd be boring.
Imagine. Sometimes I like to think about this, and we go on tangents here on the podcast sometimes. I like to think about being a human being here, even in Texas, an indigenous person like 10,000 years ago, and what they must have, especially in the winter months, clear crystal, they could probably walk by starlight.
Oh, I'm pretty sure they could.
And a moon would be
Yes, it would just be blinding almost. Yeah. You could probably actually read the newspaper by Venus coming up, in all reality.
Venus still...
It's bright.
It's very bright. And every time Venus... I've noticed this, maybe you have too.
Oh, yeah.
Is low on the horizon around rush hour.
Yes.
And it usually sticks that way for a few weeks, if not months.
Yeah, because you'll see it hanging in a certain area.
Right above the sun as the sun goes down, or even as the sun is still kind of peaking, you'll see the super bright
dot in the sky.
And the people on Nextdoor and Facebook, whatever groups, have you seen, what's that bright light in the sky? Is that a plane? I saw this big plane and like, what is it? Is it a UFO or something like that?
But it's really not moving. What is it?
Yeah, is it a supernova?
It's actually following me to work. How can that be?
Yeah.
Yeah. We've gotten the phone calls.
It's a full moon Venus.
Yes, exactly. Because Venus goes in phases. Because it's between us, the sun, and the earth. Yep. So we see it in phases. Same with Mercury, but Mercury's not quite as bright.
Yeah. And the cool thing about Venus, it's one of those celestial objects that I think a lot of us take for granted. Less than the moon, but similar, because we see it so often. But if you look at Venus more closely, you can be lucky enough to observe it through just even a small telescope.
Yes.
See the crescent.
Yes, you don't need a big telescope to see Venus go into phases.
Right.
I mean, Galileo was the original one that looked at the phases and noticed that Venus had phases and actually drew pictures of that.
And it's very trippy the first time you see it.
2-inch telescope?
If that?
Yeah.
Venus.
I mean, so you don't have to have a big telescope. You don't have to have a big telescope to look at the sun. You do have to have a special filter to see the sun.
A matter of fact, I was going to say, similar, Venus less than the sun, but Venus is so bright.
Yes.
That if you're using a camera, you're going to have to adjust your exposure down.
Yes.
Or close the iris as much as you can to actually see the crescent come out because it's so bright.
But it's so neat that it does go into phases just like our moon.
The first time I saw a phase of Venus, and it was just one of those cheap 105 millimeter, 100 millimeter cameras, Celestron, Orions, whatever. You can get them on Amazon all day long. They're at Walmart. They're probably at Walgreens. You can get them everywhere. That is all you need to see some really, really cool stuff, even in a light polluted.
Look at the craters on the moon.
Yeah.
You don't have to have a big scope to see this stuff.
I would love to have this in my garage.
We would all like to have this in our backyard.
Yeah. And we're lucky enough that we get to play with this more or less whenever we want. I said maybe I'll have to come out here another time for a different podcast or something later in the evening so we could actually
look through it.
Right.
And you can actually shoot some pictures. Because we do that.
I have adapters. I have T mounts and T adapters and also.
I mean, we just hold our. I don't know if I still have it.
But yeah, so the 36-inch scope. While she's looking that up.
Yeah, so we just hold our.
Oh, eyepiece projection.
Yeah, it's just eyepiece projection.
And that's a technical term in astrophotography. It's you aim your telescope at an object, at the moon or whatever, and then you just hold your phone. You line up your camera right with the eyepiece and click. And you get something.
And you get something like that.
But you can't. I'll put a better representation or something.
I'll send it to you. But and that's just eyepiece projection. You just hold your cell phone up.
Let's talk about astrophotography for a minute. When you mention astrophotography to a layperson or someone who's basically just getting interested in it, their mind might automatically go to, I need a big giant.
Ching ching.
36.
Big scope.
Big money and everything.
Yeah.
And that's certainly can be the case as far as depending how far you get into it. But astrophotography is also
using your cell phone.
Using your cell phone.
Using your cell phone.
And we were talking off camera that cell phones
cell phone is an ancient way to call it. These are smartphones now.
Just say are smart. They're basically your little computer.
They're cameras and computers that make phone calls.
Right.
It used to be a phone that could take pictures.
Right.
Now it's a camera
exactly.
that can be a phone. So anyways, but the sensors are so good that nothing's going to replace like a full frame or even a Micro Four Thirds, like whatever. But the sensors in here are so good now, and you get such a nice wide field of view with these smartphones that you can go out to when you go camping. Let's say you go to Enchanted Rock or something like that.
Oh, definitely.
And just keep your phone still, maybe put on a tripod or just
if you
just
don't have
put
that, find a rock. Find a rock.
And just set the exposure to 5 seconds or 10 seconds or whatever, and just watch the Milky Way explode on your screen. It's so beautiful. That is where astrophotography starts, with anything that can capture an image.
Yes.
Anything. And then it can end up,
eventually you might want to, migrate to a different setup. But to initially get the bug and get you going on it, oh yeah, your cell phone does a fabulous job.
It goes from your phone to the web telescope.
And you will be surprised how well your cell phone can take a picture.
Yeah, and maybe, it's kind of a stretch. I'm going to say that there may be images that your phone is better at than the web would be.
Oh,
the
definitely.
web is definitely tailored towards the deepest sky ever that you can ever see in the universe.
Yeah, we're wanting to get deep. We're wanting to see how far we can go. I mean, with your cell phone, you're looking for a nice picture. You're looking for craters on the moon. You're looking, for a lunar eclipse or something unique, something so you can remember.
Exactly. The web wasn't specialized to take more pictures of the moon.
Right.
I'm sure it certainly can. But the moon is so bright.
Yes.
Your phone is more than capable.
Fabulous for doing that.
Maybe your phone can't necessarily see the beginning of time, the microwave redness.
That's what the web's for.
But that's what the web's for. And even the Hubble once upon.
Right.
I kind of feel bad for the Hubble now a little bit. But again, even the Hubble is tailored for different things.
Yeah, and depending on its cameras on board, it shoots different than what the web shoots.
Right. So astrophotography can start with what is in your pocket.
Right.
If you are listening to this podcast, you almost certainly have the equipment necessary.
Oh yeah, anybody has the equipment.
Now, don't go aiming at the sun, or you got to be very careful with that. And I was looking when I was preparing for the solar eclipse.
Do make one to put over your cell phone.
I know. That's what I'm getting at.
Yes.
Is in photography and videography called ND filters, where you can control. It's like sunglasses.
Yes.
For your camera, and you don't just need regular sunglasses. I thought I had them on. You need. It's almost like looking through an old vinyl record. It's a special filter, and you can't see anything through it until you look at the sun. Yeah. And I'm telling you, it's for photographers, videographers, we're thinking like ND2, ND64. Right. For the sun, it's like ND 100,000.
Exactly.
It's really dark.
Yes.
But that you put the filter on it, or you can put the filter even in front of your phone lens.
Yes.
Put the zoom at 5x or 10x, whatever. Aim it at the sun with that filter on it. You'll see sunspots.
Exactly.
You'll see the pockmarks on the sun.
You'll see cooler spots on the sun.
With your phone.
Yes. You don't, like you say, you don't need much. Your phone does a fabulous job.
Just get out there and take a picture. Not like, in like wildlife photography, people might think, oh, I need to have David Attenborough with me and a big giant $60,000 600 millimeter zoom lens to take a picture of this turtle.
No.
Maybe that will get. Well,
if you want, the golden award from National Geographic, maybe.
Right. But don't let that intimidate you from just
using your cell phone.
They've gotten so good now that you can really take some
sophisticated shots. Yeah.
And I was telling you off camera that one of the best pictures I ever took, astrophotography, was the occultation, which just means the alignment of the moon and Jupiter.
Yes.
Back in like 2012 or 2013. It was the winter.
It was 2012.
I think it was like 2012 going into 2013. It's like December 2012.
December going,
I had an old digital Pentax.
Oh yeah.
It wasn't a mirrorless. It was a DSLR.
Oh yeah, a flip lens. Yep.
And I don't think you even had a preview screen on it. You just had to snap it and then you offload the card and see what you got.
Right.
But with that ancient digital camera and just whatever kit lens that I had with it, it was like $150 Craigslist thing that I got. But I took my most favorite astrophotography picture that I've yet to take, and it was the moon in a phase It wasn't full moon.
Oh, yeah.
So you could see the shadows being cast over the mountains and over the craters.
Oh, yeah.
And then right in the bottom, the same image, same exposure. It's not a composite. Same snap is Jupiter. And you can see the bands.
Right.
You can make them out. And I was like, I probably, until my kids are born, I probably won't take a better picture in my entire life. Like the only thing better than that picture is like pictures I have of my kids.
Oh, yeah.
But that picture is so beautiful.
But it's a picture of the moment.
Of the moment.
That you remember, you know?
And you don't even need...
But you don't have to spend thousands upon thousands to do something like that.
No, and you don't even need to take a picture at all.
Exactly.
I'm getting on my tippy toes. At all.
Yeah.
You can just... it is perfectly okay. I know this goes against the grain of everything. I'm part of the social media marketing team here, so it goes against the grain of what I do. Just put the phone away. You can just be in the moment.
Exactly.
Old-fashioned way.
Sometimes it's worth that. Sometimes I get the Chase lounge chair, just sit back, watch the Milky Way rise. You know, sometimes it's just worth it. Just the serene, the Milky Way rising. It's like our galaxy. Yeah.
I know we're recording here, but my mind is just, that's like my therapy. It would just be sitting out there with some sweet iced tea.
Yep.
And watching the sun go down and the sky on fire with the orange
and
the pinks. Texas has really great sunsets.
Fabulous sunset.
We don't have all the pretty mountains of the Blue Ridge or the Rockies.
No.
But that just means that there's way more opportunity
to shoot a wonderful sunset as it's going down.
Beautiful sunset. And that, as we go through life, we'll start wrapping it up soon because it's an oven. We turned off the fans to record in here. One of my favorite things now, and I'm like the tech geek, obviously. I've got a backpack full of drones and cameras and PlayStation 5 at home. I've got all the stuff. OLED, this and that.
Oh, yeah.
But the more I appreciate no technology, just sitting, like you said, in the chaise lounge, watching the sunset.
Sometimes you just want to, just enjoy that. I mean, I'll do my personal observing of it's me, the sound of crickets, the frogs, and the stars.
Cicadas screaming.
Yeah.
It's cicada season around Texas.
Yeah.
Is there anything, as we wrap up here, we covered a lot. Can we talk about, on the way out, we are standing in front of our Guymard, is that?
Guymard telescope.
Let's talk about a little bit of what exactly this telescope is, and maybe we'll start at the history. I know we did a short video about that recently, but for the sake of the podcast, let's start at how we got it and go from there.
So how did we get this large 36-inch telescope? It originally went up for sale. Actually, Carolyn saw it.
Oh.
And the museum put a bid in for it in the mid-'80s. We won the bid. Then the quest was getting it out here.
Who was selling it?
Pardon me?
Who was selling it?
Louisiana State University. So LSU was putting it up for sale. It was an off-site campus. So the students were no longer using it. And I mean, I get that with Rice. They had the same problem here. So we won the bid. Then the quest was to get the whole thing here. And not so much the scope. We also bought the floor and the dome.
Wow.
From LSU, because they were demolishing the building. Once we got everything out, it was going. So like I said, the quest was getting the dome here.
It was a liquidation sale of
pretty much.
A giant telescope.
Yeah.
And dome.
Yeah, but it was such a steal of a deal, it was hard not to pass it up. Now the quest was, raising the money for it, but the museum had no problem getting that.
And you said in the 80s.
In the 80s, mid-80s.
When was the final, when did it open?
So bid on it in the mid-80s. We opened in October of 89.
Yep.
And we've been looking up ever since.
That's about close to when I moved to Houston.
Yeah.
I didn't know, obviously, about the telescope then. You mentioned that we couldn't put the whole dome and everything on
No,
a
you
truck.
can't just put it on 18-wheeler and go down I-10.
So it came in pieces.
It did. So we had to put the dome in pieces more so. The dome and the floor, actually, in pieces. This actually comes apart in 3 pieces, so it was no big deal I say that. You have to label all the wires, which is what we had to do when we went over there to make sure when you put it back, everything started working.
Yeah, and this is before a smartphone where you just like snap
Right, you could take
pictures of
pictures.
like
You had to
cables.
sit there and literally label every wire, and there's
Right.
probably 3,000 wires in this thing, at least, maybe more.
Wow.
But yeah, I went there and meticulously labeled them all, so each one matched when we put it back. And then it just, like I said, it comes apart in big 3 chunks. The white tube, the blue arm that's behind us, and then the blue pier down at the bottom.
And then the mirror is also
The mirrors, yeah, they got taken out and shipped separately because that is obviously the most precious part of a telescope. Without those, you just have a carcass.
Yeah, you just have a tube that
You have a
just
carcass tube.
look through it. And the mirror recently got refurbished, is that right?
It did. It got actually around 2012, 2013, we actually sent out to get it recoded.
Wow.
And so yeah, that was kind of a challenge at that point.
We talked about this in a previous video. I'll link it in the description. But it's a 36-inch mirror, and you said 5 inches thick?
5 inches thick,
5 inches thick.
550 pounds for the mirror.
Crazy. And so here's why that really matters. A, the bigger the mirror, the more light you can capture.
The more detail you'll see.
And the more detail you'll see, and the further out into space
Right.
you can observe. But also, the bigger mirror, it has to come to temperature.
It does. It has to equalize
Right.
between inside and outside. So for us, we usually try to keep it 2 degrees temperature sway between inside and outside. And even sometimes for those 2 degrees, it takes us like a couple of hours to equalize. I mean, because you're talking 5 inches of glass
Yeah.
slowly cooling down, or equalizing.
Those are the little intricacies of astronomy and stargazing that obviously a lot of people wouldn't think about because
No,
you
they
don't know what you don't know. And the bigger the glass, I usually set out my 8-inch scope, which is like a 1 inch thick.
Yeah.
Yeah. So it's an
quarter.
8-inch diameter, which is about that. And then but that's still a chunk of glass.
It is.
And it does need some time.
It does
If
to
I'm pulling
cool
it
off.
out of the garage, which is maybe 10 degrees, 15 degrees cooler than
Then where you're actually
outside,
observing,
or vice versa. If the heat of the day is built up in there and then I'm taken out to the cool of the night, you're dealing with condensation.
Right.
And on the microscopic level, that parabolic, is it parabolic?
It's a parabolic mirror, so it's like a big salad bowl.
But the temperature, it's slightly warped.
Yes, it is.
The temperature can keep it a little bit warped so that light rays coming in scatter differently.
Right.
They don't go right back up to the secondary mirror.
Exactly.
That's why you wait for it to cool down.
Yes.
So the entire surface is as level and true as possible. There's no fog, no condensation, just like that sweet tea I was talking about earlier. It
Exactly.
sweats. You don't want that.
No, you don't.
And that manifests itself, because I've dealt with this many frustrating times, of images coming out. It's like, I have astigmatism.
Oh, I do too.
I know what astigmatism looks like.
Yes.
And like, okay, I can tell by looking at the stars and things like that. Well, I don't have the best setup. And I didn't wait long enough to let
it cool.
Let it equalize or cool, whatever. So my stars aren't perfect little dots. They're little fuzzy, slightly.
Yep.
Oh, what's the big deal about that? Well, if you're trying to do a long exposure or get some detail out of something, a smudge, a nanometer of a smudge
Right.
equals a billion miles of smudge
Right.
on what you're observing.
Yes, it becomes, yes.
So that little fleck of dust, you think, oh, I can still see things through the eyepiece, or even if the mirror is a little dusty or whatever.
Right.
Well, you can see the big picture. If you want to zoom in or you want to get more detail out of it, that speck of dust has basically erased an entire band off of you.
Exactly.
Basically.
So you want it as pinpoint as possible.
So exactly. So the big 36-inch scope, so we can see real deep in the sky, takes some time to equalize. How automated is this scope?
It's just slightly automated because you got to remember this was back in the day of analog. So now we have to go from analog to digital with this scope. And we did. I mean, we used to use the dials back here is what we used to use. But then we ended up going to computers. So it reads off of our gears, our encoders back there. So we've got a big, huge right ascension, declination, which is like longitude and latitude. And it's reading off of that through our computer now.
Do you have to align it every time?
No, we don't.
Okay.
We do have to check it about once a year or twice a year just to see where the alignment's at.
And an alignment means usually at least 2 or 3 points for a good alignment, like the
Yes.
Polaris. I forget the other ones.
Polaris, usually you choose 2 brighter stars.
Okay.
Further apart from each other.
It's triangulation.
Yes, it is.
It's to get that very precise so that when you tell it slew to Pluto,
Right.
Pluto is right dead center of the eyepiece.
In your eyepiece when you're observing.
And it tracks it accordingly to compensate for Earth's
rotation,
and
yeah.
everything like that. How much does this telescope weigh?
How much? So the whole telescope by itself weighs 10 tons. So it's not light, but it's back in the day where everything was built with steel.
Yeah.
But it's American made, yeah.
It's American-made steel. So I'll show B-roll of this. We're here in the dome. This is like the attic of what really goes into this scope. Below our feet, 20, 30 feet, is probably one of the biggest slabs of concrete a foundation you can imagine.
Oh, yeah.
And there's even more concrete piled up. And then this solid steel is bolted
sitting on top of it.
It looks like 100 giant. You know those bolts that hold up like street lamps?
2-inch bolts.
Yeah, they're giant and they're all over and they hold this thing up. And with why is that important? Stability is everything.
With a big telescope.
Especially with a big telescope. I'm bumping it. My shoulder is very slightly, I guess this is a finder scope.
It is.
Over here. The meat of my shoulder is very lightly touching it. If you were doing a long exposure or trying to get some astrophotography of a nebula way faint away, my little shoulder meat hitting it, it's not even a full bump. My little shoulder meat, ruined.
Right.
You could be out here for 12 hours doing a long exposure and that little shoulder meat graze.
Yeah, you're done.
That night's wasted, or that specific event you're trying to capture the supernova as it's happening. You're so lucky. And then I would still use that image if I was getting a supernova occurring. I'd still use it with a shoulder bump. But stability is
everything. It's key to a big scope.
So that's why it weighs 10,000?
10 tons. 20,000 pounds.
10 tons. I was way off with 10 tons. 10 tons. This is so cool. It is August in Texas right now, and we have turned off all the fans. And we are, if you fast forward like time lapse this podcast on the video, you just see the sweat like
it's building on us.
So, is there anything, any evergreen you want to mention? Tell people come out here.
Well, just come on out. Book our tickets or book your tickets through the site. We're booked about a month and a half in advance right now. Which says we're very popular.
Yeah, it's a good problem for us to have. Perfect timing.
Perfect timing.
I might just went out. Perfect timing. Tracy, thank you so much for being on the Beyond Bones podcast.
Oh, thank you. I'm glad to be here.
Yeah.
Thank you so much for listening to the HMNS Beyond Bones podcast. If you enjoyed it, consider rating our podcast, sharing with your friends, and following HMNS on YouTube, Facebook, Instagram, TikTok, and all of our social media platforms. But most of all, we can't wait to see you at any of our 3 HMNS locations: our main campus downtown, HMNS at Sugarland, and of course, the George Observatory in Brazos Bend State Park. Until next time, as always, stay safe and stay curious.